Alright, now let's talk about the technological environment. This is anything involving technology that may impact business operations. Changes in technology, how a company uses technology, all kinds of external factors that technology may leverage on a business. Here I have a couple examples of how the technological environment can impact a business and subsequently management decisions. Take, for example, if you're a company that produces cell phone apps. With the rapid changing technology that goes into cell phones, you may be required to constantly update your software and modify it to suit the new latest and greatest phone, whether it may be a Samsung or an iPhone. That choice of platform and how it's constantly moving forward is definitely going to be an external impact on your business decisions. Or you may be a company that makes modifications for body kits for, say, that Ford Mustang. In that case, you might want to look into the aerodynamic impacts of how that particular modification is going to affect the car. So you may need something like a Cray supercomputer where you have to do fluid dynamics on it. Or if you build a product that has to operate in microgravity, such as the International Space Station. In a nutshell, you're going to have to understand how your technological environment grows and changes with time. Whether you're operating on the International Space Station or making an app for a cell phone, as the environment changes, your business and management approach is going to have to adapt to them technological changes. Moving on to the decision-making process. Now this is right out of our notes from chapter 4 for the decision-making process under planning and forecasting. At the top we have recognize the problem or opportunity. What's involved in it? Or is it a cost overrun? Are there delays? Is there new technology that we could take advantage of? Moving down from there, we look at how we can actually define the problem, what its specific constraints are, or what the opportunity actually is. We have to look at how this affects our overall mission and what the long-term objectives and strategy is of the business. Once we've done that, we can begin gathering information and also formulating what our decision may be. This begins an iterative process of formulating decisions and gathering information, looking at alternatives and seeing how them alternatives may play out. And we continue this loop back and forth and look at the feedback from each one of them decisions. Only after that process is complete we can look at implementing the best possible solution. And once we implement that solution, we should follow up and review its effectiveness, hoping that the results are what we expected. And the process will continue over and over again, refining and improving on that result. Now let's take a look at systems engineering methodology, starting off with our configuration management. Basically, configuration management is an application of sound program practices to maintain consistency across the product or system such that we can track its changes. With good configuration management, we can look at how a product or service is changed over time from its original baseline to as it evolves throughout its life cycle. Configuration management is a concept that was originally developed by the United States Air Force back in the 1950s as a way of technically managing hardware and the discipline of hardware. Since then, it's branched out into software, modeling, simulation, and finally systems engineering management as a whole. Configuration management activities include identifying and defining a baseline of a hardware or software or service, and then once you have that baseline, controlling any modifications that may be associated with it in various releases. Also reporting and recording the status of each configuration, and the requested modifications from what may be coming from the field. Once that's done, you also have to ensure the completeness and the consistency of your product or service, and this is also done with configuration management. And finally, controlling the configurations, handling, and delivery of the configurations is also associated with configuration management. A company that has good configuration management reduces its confusions when establishing various orders. It also organizes its activities to maintain its product integrity, and it ensures the correct product actually going out in the field. And on top of that, as an added bonus, it limits legal liability by providing a record of actions, and it reduces lifecycle cost. Moving on to requirements, verification, and validation. Verification and validation, or V&V for short, is a process for quality control to determine that what our product is actually meeting the requirements that are set forth from the original systems engineering model. It's a process that answers the all-important question of, is this the right solution? Breaking V&V up into its two subcomponents, validation and verification. First off, validation is three components associated with it. The very first one is reviewing of the documentation to make sure that the operational capability is actually being met. This is done through a process of testing, looking at technical data and manuals, checking for technical adequacy of the product. Finally, an evaluation of the system end to end to make sure that the product being developed or the service being rendered actually answers the question of what was originally specified. And then for verification, this process is basically looking back at what was originally designed to be built and verifying that it was actually built. This looks at the life cycle, the design solutions, and the physical architecture and software that are associated with it, make sure that the system is cost effective and demonstrates what was originally envisioned at the beginning of the project. The next step in our systems engineering methodology is our architectural design process. This is a method of determining what kind of design process is going to be used, what the scope is, what data is required, how it's going to be collected, how it's going to be organized and correlated, and then what that analysis is going to be used for. And finally, documenting the results in accordance with our stakeholders or decision makers. Both the hardware and the software development configuration and methodologies are reflected in what our original requirements are. These could be iterative builds or incremental releases. These are defined in our original build management process. And finally, there's testing. This is important because it encompasses all the requirements and checking to make sure each one of the requirements for our product or our service is actually met.